Okay, hi friends. Okay, in this particular video, I'm giving you a brief idea about the program for data transfer operation. So, in the data transfer also, let us see how to move n number of bytes from 3000 H location to 4000 H location. Let us see how to write the program. See here. Now let us see assembly language program of 8086. So in that my problem is write an assembly language program to move n number of bytes. Starts from 3000 H memory location to 4000 H memory location. So I need to move n number of bytes. Starts from 3000 H memory location to 4000 H memory locations. Let us see how to write the program. First of all, my count is n bytes. So count n bytes means we should select byte means it's 8 bit. So 8 bits means we can select 8 zeros, then equivalent xi is 00h. For example, 8 bits we can select 8 ones, then equivalent xi is 5f. Equivalent xi is ffh. So the range of byte is 00h to ffh. So in this particular range we have 2 power 8, nothing but 256 different numbers we can select it. So it is your choice, you can select any number in this particular range as a count. Now for simplicity I am selecting count is 03. So 03 is also in this particular range. So I am selecting one 8 bit count as 03h. So in order to select this 03h I need one location. So for that reason I am using 2000h memory location for count selection. Okay, so now my count is 3 and I am selecting 3 in 2000h memory location. Later what is next step? We need to select 3 numbers starts from 3000h. So we need to select 3 numbers because my count is 3, that's why I am selecting 3 numbers starts from 3000h memory location. See here 3000h memory location I am selecting one 8 bit number is 01. 3001 memory location I am selecting another 8 bit number is 02. You know already each memory location can store only 1 byte. So my aim is in this particular example I need to move 3 bytes starts from 3000 to 4000. For that reason I need 3 locations because each byte can be present only in one memory location. So 3001 memory location now contains 02, 3002 memory locations contain 03. So selection of 3 numbers are over. Then if you execute the program, what happens? So these 3 values will move from 3000 to 3002 into 4000 to 4002. So after executing, what happens? 4000 location, 4001 and 4002 locations contains 3000h to 3002h data. Nothing but 01 is present in 3000 to 4000. Similarly, 02 is entered into 4001 and 03 is entered into 4002. So based on this, we can say that 3 bytes successfully move from 3000 to 4000. Starts from 3000h to 4000h memory location. So this is the basic example. Let us see how to write the program in order to make these results. For that, what is first step? We should select DOS command. See here. So every time we should select DOS command. Now let us see. There is a DOS box icon here. See here. Press this DOS box. Double click it. Okay. We get this type of screen. Then you type mount. M-O-U-N-T. Mount space. So where our 8086 is available in last video I explained. So 8086 folder is available in my D drive. That's why mount space D drive. For that mount space D space D colon slash enter. Then again in order to select the D drive D colon. Now Z is transferred to D. Now we are in D drive. In the D drive we need to enter into 8086. For that CD space 8086, then enter. So in order to type program, we should write edit. So now we are in D drive. In that D drive, we are in 8086. In that 8086, we are selecting edit. Then we are generating a fresh program into 8086. Enter. In order to make full screen, you press Alt and enter. Okay, we get this type of screen. Here, let us see. First step. So I already mentioned for every program, starting of the program, we need code segment. So code segment. Assume directory is essential. CS colon code. assume CS colon code, then enter. What is the next step? Start indicates start of the program. Okay, these three steps are essential for writing any assembly program. Okay, next, what is next step? Now we should write our program. First we should clear all the general purpose registers. So now in my program I need AX register, that's why I am clearing AX. So BL may not required here for this program, but count register is required because I need to move n number of bytes for the CL. So move CL comma AL. So in first instruction what happens if you write exclusive or X comma AX? So if you perform exclusive or operation of AX with the same AX, then your AX is cleared. Nothing but AL and AH both are cleared. So the next instruction, AL already cleared in first instruction, then that AL data is now moved to CL. So CL is also cleared. So after executing these two instructions, what happens? AX is cleared and CL is also cleared. The next step is, now I need to select the count. For that I need 2000H location for selecting count. So move SI comma 2000H means what happens? SI is now equal to 2000H. The next step is L comma box of SI. So in this instruction, CL takes data from 2000H memory location indirectly. Okay, this addressing mode is called it as a register indirect addressing mode. Indirectly, my CL takes data from 2000H memory location through SI register and uses this SI register indirectly. Okay, so now CL finally takes count value from 2000H. So in this theoretical example, we are selecting CL is 03. So we can select 03 value 2000H. I will give you how to select 03 in 2000H during the running time. Next step is count is over. Then we need first location, nothing but 3000H. For that I am using one register SI with 3000H. Then for destination also I need another location. For that I am using one more register DI. SI for one set of locations, starting locations, DI for destination locations. Means 3000 data is now moved to 4000, 3001 data to 4001. For that we need two registers, one from starting of first memory, other register starting of next memory. Then next step is because the 8086 in 8086 we don't have any transfer of data directly between two memories. One must be memory, other must be register, or both are registers, but not both are memories. That's why every time in order to transmit data from one memory to other memory, we should send data from memory to register, then register to other memory. Now move AL comma box of SI. So in this instruction what happens? My AL takes data from 3000 location. So now first data is now available in AL. Okay, it will take AL takes data from 3000 location. What is next step? I need to move this data into DI location. For that, box of DI comma AL. So AL receiving data from 3000 location and that particular data is now transferred to 4000 location. Like that, 1 byte is successfully transferred from 3000 to 4000. Like that, how many bytes I need to move? Until the selection of count. For example, count is n, I should repeat same operation for n number of locations. For that, increment SI, then what is my SI? 3001. Then increment DA. What is DA? 4001. Then I need to repeat same operation. For that I am using one instruction, call it as loop space L1. L1 is a one label where I need to indicate this label nothing but it's like a tag. So if you execute this instruction, it will go L1 where L1 is there. Here I am writing L1. What is the function of L1? First, let us see what is the function of loop. So I already in the instruction set of 8086 I explained what is the role of loop. So loop instructions performs two functions. One is for every loop instruction, the content of CL register is decrementing by 1 and checking whether CL is 00 or not. Two functions it will perform. Decrementing the content of CL by 1 and checking whether CL is 00H or not. Initially, for example, CL is 3. Okay, in one example, CL is 3. Then what happens? AL takes data from 3000 and AL sending that data to 4000. Then incrementing SI. What is SI now? 3001. What is DA now? 4001. Then it will go to next loop instruction. In loop instruction, what happens? My CL is decrementing by 1. What is CL now? 03 is decrementing by 1. Then my CL is 2. Is it 00? No. Then this instruction is executing. It will go L1. Then my AL takes data from 3001. Then the data that is available in 3001 is now moved to 4001. Like that, data is transferred from 3001 to 4001. Then again SI is incrementing. What is SI now? 3002. And what is DA now? 4002. then again loop. Because of loop, what happens? My CL is again decrementing. What is CL now? 0 2 becomes 0 1. Is it 0 0? No. Again it will go. Like that, this loop repeats for how many times? 3 times. Okay. Then when this loop failed, whenever CL reaches to 0 0, then it will fail. When once it is failed, it will comes out of the loop. Means it comes to next line. So in that I am writing int 3. Int 3 indicates end of the program. If I write any instructions after int 3, processor it won't execute. Okay, int 3 instruction is nothing but end of the, call it as a body of the program. So body of the program for move operation is over. Then what is next step? At the end we should write code ends for end of the code segment. Then code ends end, start also end. Okay, this is the program for transferring n number of bytes, starts from 3000H to 4000H. So now what is the next step? Save. So here file name is, for example, data1.asm. Okay, so data1.asm, data transfer operation of first experiment, that's why I am calling as data1.asm. Extension must be asm. Okay, then file, exit. Saving is over, then exit. So here you should type commands. What is first command for writing any program? So in previous video I explained various commands for executing the program. First one is masm space file name. File name is data1.asm. Enter 4 times, 1 2 3 4. So no errors. Okay, then what is next step? Link command, link space file name data1.obj 4 times, 1 2 3 4. Then debug file name data1.exe 1 time. Okay, then run command. What is run command? G equal to 4 zeros. Okay, running is also over. What is the next step? After running, we should select input values. For that, E space count. First, we should select count. So, in which location we need to select count? 2000. For that, E space 2000. So, in that location, already 7F is available. So, now I need to modify with, for example, 03. As per theoretical example, 03. That's why I am taking 03. So, my count is 03. So I need to move 3 bytes, starts from 3000 to 4000. So count selection is over. Then what is next step? I need to select 3 numbers in 3000 locations. Starts from 3000. I need to select 3 locations for giving the inputs. So that's why I am writing E space 3000. In that, what is first number? I need to select 01. In order to select next 3001 location, simply press tab. We get 3001 location. In 3001 already 06 is available. So I am modifying with 02. Next tab. Then 3002 location. In that 00 is available. Now I am writing 03. Like that I am giving 1 in 3000 location, 2 in 3001 location, and 3 in 3002 locations. So I am giving new inputs. Then again run the program. Then only processor will take these new bytes. Otherwise it won't take. Okay, G equal to 4 zeros. After running, what happens? We need to see results. Where I need to see results? 4000, 4001 and 4002. What is command for seeing the output? D space where my result starting is 4000, ending locations for result is 4002. If we execute, if it enter this particular location, we get result is 01, 02, 03. Verify. So 4000 location contains 01, 4001 contains 02, and 4002 contains 0. It indicates that successfully 3 bytes are transferred. Starts from 3000 to 4000. Like that, not only 3 bytes, we can transfer n number of bytes. Starts from 3000H to 4000H. Okay, this is the program for transferring n number of bytes. So in order to exit from this, make it quit, then exit.